All right, let's go ahead and take a look at some examples of these factor type questions. That's what the students seem to be calling them. A lot of people have had questions on these, and they're not currently having the desired effect. The basic idea behind them was actually to try to reduce the amount of math necessary on the test. And I think what's happening instead is people are panicking and misunderstanding and doing more math on the test. So I'd like to get that going back in the right direction. One of the biggest things that you need to do first when you're looking at one of these questions is you need to relate it back to whatever the original version was that we worked previously. So in this case, you can role play, and this can be you. A student calculated something. You could have been that student, right? You should have your blank notes if you printed them and wrote on them, or if you took notes in class or from a video lecture or during the analytical assignment. You should have a version of this question already. And if not, then go look it up and make one. And then a student works a new version of the question. Again, you can quite literally make a new version of the question. If you print the blank notes, there's two spots for each question. And you could print a couple of copies of those because you could use one for your analytical assignment homework, and then you could use the other one later to help, get ready for the test. Another thing that students are having issues with is you do have to read very, very carefully that sometimes a student will tell me that they did two versions of the question. They were exactly the same. They got one right and missed the other one. And almost always that ends up not being true. So you have to pay attention. Most of the questions going to be the same. In fact, if I scroll through these quickly, you can see that very little changes in these. I mean, I've highlighted, quite literally highlighted the difference to show you what's going on. But the initial setup, the formula, most of the numbers, most of the words in the question, the original reference, that's all going to be the same. The factor is typically going to be randomized. Today, to be consistent, I just use the same number because it doesn't really matter. But there's one little bitty difference at the end, and I think students are missing that. I think they're seeing a long question, and sometimes test anxiety sets in, whatever else happens. But you need to look for that carefully. So from this example question, we're talking about centripetal force. It's the second question from week 4, or if we go by our modules, that's week 2A, and then question 2. So that's another way to look for that one. Centripetal force comes from mass times centripetal acceleration, but we can combine those formulas and we can do this one right here. And so in the example, again, you should have some version of this already written down. These were the original numbers worked in the class examples, and this was the answer. So now, a new version of the question where the mass changes. Okay, so our new mass, m prime, means that the mass has changed from whatever it was before, is going to be equal to 0.567 times the original mass, right? So that means that we would take the 1434 from the original number, and that's going to be multiplied by that factor number, that decimal. I mean, technically, I changed the order of multiplication, but that's not going to hurt anything here. Okay, and then so from that number, this mass is going to turn into something like 813 point, we'll say 1010. And so you can write that in, and you can literally work a new version of this question like it suggests, and you can see what you get to. What you want to keep in mind here is that the new velocity is the same as the old velocity, and the new radius is the same as the old radius. Nothing else changes. It's only one part at a time. So if we look at this, the mass is going to be different here, but we are going to have the same 1964 from this first part. And then we're going to have the same 189.67 that's on the bottom. Again, the only thing that has changed, and to make that very clear, I'll even change the color on it, is that the mass became 813.10. Okay, so then what that's going to give us, if we run through and we calculate this part, we're going to get something like 1653 points, we'll say 59. And then notice that that's not any of these answer choices, right? So this, I think, is another spot where students were panicking. We need to determine the factor by which the answer changes. So factor means that you're dealing with, depending on the setup, multiplication or division. We're comparing things. Basically, it's asking, what do I need to multiply this number to turn it into that number? And because we're working backwards, we can find that actually through division. So it's very important on the order. If you take your new answer divided by your old answer, then that's going to get you in the direction you want to go. So in this case, we got 1653, and then originally we had 2916. And then when we divide those, units cancel. They should have been the same. If not, then double check because something's going wrong. And this is going to give us something like 0.566 and a bunch of nines and then some other numbers. So I think it's clear that that is really very close to 0.567. And if you're comfortable with these types of questions and the fact that certain things don't change, that's where the little shortcut and alternative strategy was presented in the test review. The only thing here that changes is the mass. So another way to get from this is to use this formula and then only change the mass. Everything else can be a simple number like 1. So because the new radius over the old radius, it's the same. It would have a ratio of 1. Technically, we can take the small shortcut and we could have plugged that straight into this question. So that alternate format, which again I showed in the test review, we would have had the m changes by the factor. So we plug in the factor, and technically it's m over m, that just goes away. Then we would have 1 squared and then over 1, which gives us that same number back again. So notice that if you're comfortable with the format here, this really didn't require much or any math. It would have been much quicker to get here. But if that's not a method that you like, then by all means, you can go through the brute force method, actually act out the question, do what the thing says, and then most importantly, remember to divide at the end. So like I said, that's sort of the final little hurdle that I think was catching students. Divide your new answer by your old answer, and either it will give you an answer choice, or if it doesn't match anything, then it's probably the answer choice that basically says that it doesn't work. Okay, so let's try that for another one of these. Same question. We'll even use the same factor just because, and then we want to see something else change. So in this one, new clean question, this time the radius has changed. Okay, so looking through, we're going to do a similar strategy to how we started this first one. So if we look at our variables, if we look at this equation, m prime, the new mass is equal to the old mass. That one didn't change. The new velocity is equal to the old velocity. Again, that one didn't change. But the radius is changing. So the new radius is going to come from the factor multiplied by the original number. Okay, so again, just like we were doing up here, but we're changing a different variable this time. Okay, so we want to multiply these things together, 0.567 for the factor. Then the radius was highlighted here, so 189.67. And then that's going to give us something like, we'll round it, 107.54. Okay, so that's what we can plug in here. And again, just like we did before. So we're going to plug in this number. We're going to pretend it's a brand new question, and we're going to work it through and see what it does. So the mass didn't change. So we bring that down again. We use the same thing. Sorry, my pen is acting up just a little bit. The velocity didn't change. So again, that one's going to come through just as it was. And then on the bottom, the radius does change. So let's put that in a new color. So notice that we're dividing by something smaller. The thing that we're adjusting is a denominator here. So it's going to change differently than just giving the factor back again. If you think about it, if you're dividing by something smaller, then it's like sharing less and you should get a bigger answer. So if we calculate this one, we should get something like 5143.54. And again, that shows, that we got a bigger answer. Then to see what this is going to make, like before, take your new value divided by your old value, and then see what's going to make. So we're going to have 5143.54 divided by the original 2916.39, and then that's going to give us approximately 1.763668, and so on and so on. So that's going to be, plus or minus a tiny bit depending on where you rounded and how you used your calculator exactly. But again, I think that's fairly clear that it's going to be an answer choice here. So far, we've seen an example where we just got the factor back again, and then this one, because it was in the denominator of the equation we were using, that is the reciprocal to the factor. So you can use those terms and strategies when you're working on your discussion questions as well. A lot of people are not given real great explanations. They're just saying this one's too big and that one's too small. But these answer choices are typically going to be the factor, the reciprocal, the square or square root of the factor, or sometimes a combination of those. And that's where those numbers come from. So in this case, if we were explaining this for a discussion, well, the factor is incorrect because that would have been how the mass changes, and this question is about the radius. And then, you might be able to take a clue for where the next one's going to go, but let's check it out and see. All right, so here, same thing, same strategy, work it through, be systematic with it so that you don't have to, make individual random choices. Work through each little part. So our new mass is the same as our old mass. We're changing velocity, so nothing else is going to be messed with. So here, look, our new velocity is going to come from the factor 0.567 multiplied by the original velocity. And then we'll work that out in a minute. Then the radius, so new radius, r prime, just means it's a radius that may, have been updated. It's a new version, new question. Sometimes people use like r1 and r2, but that's the same as the old radius, no update there. So we want to work out and we want to see what this is going to make. So we have that factor, we have the velocity, which was 19.64. And so that's going to give us something around, this one kind of in the middle, so 11.13 or 14, depending on how you might have decided to round. But okay, that gives us a place to go. So 11.14. Then we start plugging in stuff. Mass is unchanged, so we just bring that down or bring it over, depending on where you're looking. Then the velocity has changed, so I'm going to come back to that one in just a minute. Remember, it is still squared from the formula, and then the radius is the same. So I just wanted to finish those things before I changed my pen color, so I didn't have to go back and forth quite as many times. Okay, so this is the one that changed. Before we can see it's 1964. Now we're using 11.13 or 11.14, depending on your rounding strategy. And that's going to give us an answer on this part of 937.59. Notice that is considerably smaller. And the reason that happened is the factor is affecting this number right here. So it is, it's less than 1. It's going to multiply. In fact, if you round very roughly, it's around a half, right? So that would make the answer half as big, but it got squared. So it's going to be half as big again, right? It's going to be nearly in the range of like dividing by 4. So as we're going to see, that's not a perfect answer choice, not a perfect estimate, but we do expect that it's going to get a lot smaller. To figure out the exact amount, I guess process of elimination on choices probably would get you there. But let's work through and see what it really is. So we'll take our new value, divide by our old value. So that's going to be the 937 divided by the original 2916. And then, like before, the units cancel, the numbers break down into some decimal. So that's going to be approximately 0.3214889, so on, which again is a fairly direct match. This could be a little tiny bit off, plus or minus, your rounding and what you put in the calculator, but that should get us in the right direction. Okay, then one more. So let's look at what changes on this one, just because students ask me sometimes when to pick other choices or what to do. This says gravity. Gravity is going to change. So if we look, okay, the formula requires mass, velocity, and radius. So the new mass is the same as the old mass. The new velocity is the same as the old velocity, and the new radius is the same as the old radius. Where's gravity? Do we see gravity anywhere? So sometimes it's going to come out that the variable or the thing that's being asked to change is basically just gibberish. Gravity doesn't matter here. I mean, technically gravity is required for, you know, something to stick to a surface, um, but we're not calculating that. It doesn't change our answer here. And so, you know, if we go through and we brute force calculate, we're going to have exactly the same thing we had before. None of our variables that were actually useful changed. Gravity changed, but it doesn't contribute. So, you know, think about that. What would that do to the answer? And, you know, I hope you would guess that it's going to come back. And because gravity, again, is just not here, we get the same answer we had before. Now, occasionally, a question is going to be overly complicated, and it will be one of these things, and you'll come out and you'll get an answer that doesn't make sense. So, you know, be careful with that too. The sort of like outlier questions or outlier results, rather, things that can happen, is that when you divide these, you get one that's basically just not one of those numbers. But occasionally, the last answer choice is split into actually two different choices. So if you get a number that doesn't match at all, and it's not specifically a 1, if it's just some random number that seems unrelated, then that would mean that it would not make sense. So technically on this one, because we took the ratio and we got exactly 1, to be very specific, we would say that it does not change. Now that's still the same answer choice here, but that's what we're looking for. Say we had done this in some other question and we got down to the end and we got like point, well, I don't know, let's go the other way. Let's say we got an answer of like 4.567, whatever, something that was really huge, clearly different, then in that case it would have been one where it says it does not make sense. Okay, so that should hopefully help. If you have any other questions, send me an email or a course message or talk to your instructor if that is not me. But otherwise, good luck on these.